Alright, I'm Jeff Migliore.
I'm Frank Schreiber.
And for our final project, we made radio communication between two microcontrollers. For the input of the data, we used the app terminal through the computer. So we needed two radio peripherals for each board. We for this project use a Nexus board and an Atmega SDK 500, and we would use the PC with the hyper terminals for the input.
Alright, so here's a quick diagram of what we intended to build. We were going to connect the microblaze with the radio using the SPI port and using an interrupt service routine to actually call when it had data. And then using the GPIO, we were going to display onto the LCD what we were getting actually through the radio. And then for the on the Atmega controller, we were actually hooking up a computer to it, going through the USART and connecting to the controller, which was again using an SPI and the ISR to connect to the radio. Here's a quick diagram of the USB connection to the Atmega controller, and then communicating with the Nexus board.
For our design, we would be using the microwave software processor for the Nexus 2 board. The Atmega processor actually is a hardcore processor, so there wasn't any setup we had to do for that. The process starts with one user on the terminal, and they will propagate the data from the terminal to the LCD screen of the Nexus board.
So when we got down to working on this, it actually ended up being quite a bit more difficult than we originally intended. And we weren't successful to get the Nexus board to actually interface with the radio. The setup actually is quite strenuous. You have to go, it's quite a bit more than setting up the LCD, and we hadn't intended on it taking that long to set everything up. So we ended up getting it all done on one of the Atmega boards, and just grabbing another Atmega board and using the same exact interface to actually just do radio communication between the two Atmega boards, since the setup was the same on both of them.
Yeah, the software for the radio communication is very complicated. There's a lot of different processes we had to do for like the packet loss, and there's acknowledgments, and there's checksums for all of the communication to make sure the data correctly got to the receiver. So a lot of that coding was, a lot of time took in that coding just to get all the work on one side before we had to set up the Nexus board. So the testing involved confirming that the data was valid throughout the whole propagation from the user input to the board, to the SPI, to the peripheral, through the airwaves, to the other side. And for our demo today, what we have is just our two boards communicating with the Atmega.
So basically we just have two hyper terminals on the two computers, and then communication from one to the other through the hyper terminal. A hyper terminal on each one.
You had some familiarity with the 18 megahertz before.
Yeah, a slight familiarity with it before.
Did you use the radio receiver in that before at all?
No, I had never
So
used the radio receiver before. Yeah.
It's all brand new, so. But you still have communication.
Yeah. So we have some communication, just not to the Nexus board.
Well, still that's impressive.
And you had communication from the computers to the Atmega boards, which I'm sure wasn't trivial either.
Through the hyper terminal, yeah.
Yeah.
So,
okay, so we can demonstrate it if you guys want to.
Oh, this is not cool. Is that better? Yeah. Let me squeeze in between you two here. So which one's going to be sending, which one's receiving?
this one's sending right now. Okay, so basically we have it set up to take in single characters and then build them into packets, and then send a packet of 4 characters right now. So you can see
G's, yeah.
the G's over there, and then this is not going to work actually. Screw it up.
And if you just add the character in and add space, it'll take the last character you put in.
Okay, so
Full up.
it's got the F.
There you go.
There. Okay, that's what I intended.
And so it takes anything from the whole ASCII tree. I mean, there's like 0 to 255 values. There was a lot of manipulation we had to do, a lot of converting from hex to integer and back and forth, because the actual radio waves send over ints, and then we had to convert it back to hex and back and forth, and it was kind of strenuous in that. So we have all the full character set working.
It actually sends the data in 2 separate bytes, and then when we receive it on the other end, it's actually stored basically in like a hex value, and we had to convert it back into the two hex values. We had to convert it into an ASCII value, which took quite a bit of time to go through everything.
So the hex values were.
It actually comes in like as basically like ASCII hex values. Like instead of a 15, it comes in as an A or an F. And so you take that F and you have to basically put it all back together to put it into an ASCII value again. Like an actual ASCII value. Instead of the F for 15, you have to put it into whatever the two numbers add together to make your ASCII value.
The ASCII code.
Yeah, exactly. So the
Yeah.
first one multiplied by 16.
It gave the digits in separate packets. So we had to actually manipulate, like this is the second digit, this is the first digit, and then we had to convert those into one value for the printing of the character. So since it sent one in each, it sent each like int value individually with the checksum.
So you have these boards. Are they yours or the ME department's?
No, these are the ME departments.
Okay, so you're able to borrow them.
Yeah.
If you had to buy them, how much?
Actually, not too much. I think the radios themselves are like maybe $30 each, and the boards are probably somewhere around like maybe like 15 or 20. So it's not too bad.
$15 or $20?
Yeah,
for
I
a
think so.
board?
I think it's something around there. I don't believe that they're that expensive.
Something to think about. Well, thank you. Well, interesting time.